Good morning, Year 11. Today we are going to look at half equations and we are going to try to understand them, and we're going to remember that half equations always show the movement of electrons. So really what they're doing is showing an atom being, or losing electrons I should say, to form an ion, or they can show an ion gaining electrons to form an atom. So if we take the example that's in your books of sodium, if I were to draw a sodium atom like we had been doing in class, I would remember that sodium's atomic number is 11. So that means that sodium will look a bit like this. So it'll have its nucleus in the middle. Then, like we talked about in class, there'll be 2 electrons in the first shell, 8 electrons in the next shell, leaving then 1 electron for the outer shell. Now you could all tell me, no problem, that sodium will lose that outer electron. It will form a sodium ion then, and I'm hoping you remember that that sodium ion will have a 1 plus charge. So if I were to draw the electronic structure for sodium, a sodium ion, there is there. So I could write a half equation to show this process. So I have a sodium atom with its 11 electrons, losing 1 electron to form a sodium ion, and there's the electron that it lost. Now what I'd like you to do is copy that half equation into your notes at the top of, I'm just looking for the page number, at the top of page 87. Okay. Now, you'll notice at the top of page 87 as well that it does talk about that half equations can also be written for the formation of ions from a molecule of the diatomic halogen. So if we take an example then of chlorine. Now we learnt in class that chlorine is in group 7, hence it's a halogen. We learnt that it's one example of elements that are diatomic, and we learnt that diatomic means that there are 2 atoms joined by a covalent bond. Now if I were to draw out an atom of chlorine, and I'm only going to draw 1 atom of chlorine, we'll remember from class that chlorine's atomic number is 17. So therefore an atom of chlorine will have 2 electrons in the first shell, 8 electrons in the second shell, leaving 7 electrons for the outer shell. Now if I were to ask you to convert that atom of chlorine into an ion, you would all tell me that that atom of chlorine needs to gain an electron. So if I quickly draw it, it will gain an electron to form a chloride ion. Okay, and we always show, remember, like we learned earlier on in the year, we always show the electron that it gains as being different. So I'm going to show it as a red dot. Okay, now if I were to draw out a half equation to show this, I would say that the symbol for chlorine is Cl. It's gaining 1 electron to form a chloride ion, and a chloride ion, like we all know, because it's gained 1 electron, has a 1 minus charge, or just a minus. Now it's a wee bit different from sodium because I said at the start that chlorine is diatomic, so I'm going to add a 2. I'm going to add a 2 in front of this because there'll always be 2 chlorine atoms. That means that each chlorine atom is gaining 1 electron, so overall they'll gain 2 to form 2 chloride ions. Now I could show it like this: the diatomic molecule of chlorine, Cl2, gaining 2 electrons to form 2 chloride ions. Now I'd like you to write these examples into the top of page 87. Now half equations can be tricky, but use the examples in this video to have a go at the rest of the examples on page 87.